Hi, and welcome to section 8.2, where we're going to be estimating a population proportion. This is putting it all together, four-step process to confidence intervals. Now, the way we're going to do these problems is in a four-step plan. There's reason for that. On the AP exam, you're going to need to answer it in this four-step way because that's how they're going to be looking to score you. First part is the state. This is probably the easiest way you can get yourself a point. The question is what parameter you're trying to estimate, state what parameter you're trying to estimate, and at what confidence level. Usually, all you have to do is look at the last line or two of the problem. And copy it. Copy it completely. Yes, copy it down, and you can possibly get yourself an E for that part. Then there's the plan. This is where our assumptions and conditions come in. In order to get full credit, they must be in context. Your assumptions are the same ones we covered in Chapter 7 for proportions. The random condition to make sure that our sample is small enough. We're checking to make sure sample size is small enough. Sampled values must be independent of each other, meaning we had a simple random sample. If the problem states that a simple random sample was taken, you need to write a random sample of whatever they're talking about was taken. And that condition would be satisfied. Of course, if the problem doesn't say that it was a random sample, then you have to go into more detail and apply this 10% less than 10% condition. The sample in your sample size has to be small enough, remember? So that means the sample size has to be less than 10% of the population. If you're not sure if that's true, then you can always assume it. You can assume this. All right, then the second one, large counts, meaning the sample size is large enough. So to check that one, usually do have to apply the condition in order to check it off. And that's your number of successes and number of failures. The n times p hat is at least 10, and n times 1 minus p hat is at least 10. You need to add some context. Don't forget the context, even if it's an abbreviation. Oh, I wanted the word forget there. Don't forget context. All right, do. We say if the conditions are met, perform the calculations. With conditions met, we can construct a whatever interval they're looking for. It's usually either 90 or 95%. Now we have this lovely formula. We talked about Z star, we talked about P hat. P hat, remember, is your sample proportion pro. I cannot spell this afternoon. I apologize for that. I'm anticipating snow and my mind is just elsewhere. So sample proportion. Now, I was having a conversation with Ms. Hankins, and some students were getting confused on what the proportion was. If it said like 12 out of 40, that means that your proportion, p hat, is 12 over 40. Z star. can find that on that table. Look at bottom of t-table. And looking at this square root, p hat times q hat. Do not get freaked out by that q hat, please. Remember, q hat is just another way to write 1 minus p hat. I don't know why I put it like that. I should have just left it as 1 minus p hat. Now, I promised you before in the last section that finding that sample size was the hardest math you're ever going to have to do in this class. So, of course, after you have all your values, you don't even have to write the formula. You just have to make sure you name the interval. You write the name down that you're doing. And you can even copy the name that's in the calculator, because you're going to do a 1 proportion, it says prop, z interval, and it says int. And you can write that down. We are going to go to stat in our calculator, hit that lovely stat button, arrow over till you see test, and then scroll up and down, up or down. I usually go up until you see 1 prop z int. Now, there is a 1 proportion z test. We are doing an interval right now, so make sure that you find the int part for interval. Then, the last point that you can get is for your conclusion. And again, you could go back to the actual problem and rewrite the last line. And you just say, I am whatever % confidence that the problem was about, confidence level, that the true proportion of whatever you're talking about, cats, dogs, penguins, cheese pizza, I don't know, within the falls within the interval in those 2 numbers that the calculator gives you. And you're done. Short, sweet, end of discussion. Okay, so I'm trying to keep this under 20 minutes today. Let's see if I can do it. Here's our problem. Bam. Okay, that thingy is on and I'm not liking it. Computers. Just think, back in my day, you wouldn't be able to access this on the internet. Pretty cool. One day I could probably stay at home all day and teach. Example, your class has a jar of beads. I don't know why beads. Beads are boring, but anyways, here we go. Wants to estimate the proportion of beads that, this thingy's in the way, that are blue. A random sample of 250 beads. Stop. What's 250? That was a random sample. Note to self. Random sample. 250 is? Yes, that is your n equals 250. We need to know that. There are 107 blue beads, so 107 blue. We want blue, so p hat equals 107 blue out of 250 total beads. These are all notes, says I'm writing on the problem. And we also are told, this thing is not moving away, move, that there are 143 white beads. So 143, that's your 1 minus p hat, the failures, equals 143 over 250. Yay, you don't really need to write all that. And it says, calculate and interpret a 90% confidence interval for the true proportion of blue beads in the jar. So state what you want to do. I want to calculate and interpret. I don't know why I capitalized that. Interpret a 90% confidence interval for the true proportion of blue beads in the class jar. Please don't moan and groan that you have to write all this down, because you're getting a full point for it. As Danny Kertner said, we get a whole point for just doing that. I said, yes, you do. Now, plan. What do we want to do? We need to we need to calculate and interpret that 90% confidence interval. So the first condition that we had to check was, do we have a random sample? Back it up. Oh yeah, we highlighted random. So we could just say we have a random sample of 250 beads. Check, done. Second one, do we have at least 10 successes and 10 failures? Put context on that, Ms. Plochek. Do we have at least 10 blue and 10 white beads? We have 10, at least 10 blue beads. And in all actuality, there were 107 blue beads and at least 10 white beads. Remember, we're doing this to make sure that the sample size is large enough. If we don't have at least 10 successes and 10 failures, we cannot continue. And there would be a part B to this problem saying, why can't you continue? What's wrong with this problem? What if we added more beads to the situation? So back up to where we were. White beads, there was 143. Done. Check. Why did we check these conditions? Think, 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 think. What do we want to be able to use? What is STAT? This class centered around, it's centered around that normal model. So with conditions, because everyone wants to be normal. No, don't be normal. Conditions met, we can apply the normal model for a 1 prop z interval. Now, you name it. We should put in here at 90% confidence technically. Just to double check and make sure they're not going to get nitpicky about some silly thing. Technically, you don't need to write the formula if you name the problem. So because we have this name there, we don't have to technically write the formula. Now, the formula says statistic plus or minus critical value times standard deviation of the statistic. Well, yeah, that's a lot of words. Basically, math-wise, what we're doing is p hat plus or minus your z star times the square root of p hat times 1 minus p hat all over n. Now, because I wrote that formula down, I don't have to write this part in black right here. This whole formula, I don't have to write that. Math-wise, because I know some of you are math geek lovers and we have to make you happy, I'm going to actually put in my numbers. 250 plus or minus z star 90%. Look it up on the table. It should be 1.645. Yes, unfortunately, you will probably start memorizing that, even though you could really not want to. But, okay, this part looks crazy. I know Arthur's probably commenting on this. If he's watching, Arthur, I hope you're watching finally. Divided by 250. Yeah, that's a lot of numbers. But don't worry, the calculator's going to do it for you. And what did I say earlier? Oh, yeah, all the stuff in black, you don't need to write. We don't have to write all this. That's just so you see what's going on, because you're going to add and subtract, so you could fall on either side of that p hat that's in the middle that I don't even know yet because I haven't calculated it. What I do want you to write is first go in your calculator. Oh, I don't know how to do my calculator on this. Note to self. Figure out how to get the calculator on the smartboard. I know there's a way. Miss Thomas always tells me there's a way. Okay, go find your 1 prop z interval. Remember, it was stat over to test. Find 1 prop z int. It's going to ask you on your calculator, it's asking x. Well, you could write x down. That's probably a good idea. Let's write what you put in the calculator. X equals 107. And then it'll say n equals 250. And then it'll say confidence level equals, and you put 0.90. and then calculate. And when you hit calculate, it comes out with a p hat of, what's the p hat? Oh, you know what? I never even found the p hat. Well, the calculator tells you the p hat. You could write that down. And I definitely want you to put in here z star. That is something you have to look up. The calculator's not going to tell you. It is 1.645. You don't have to put the plus and minus with it. And then it gives you your interval. And you just write the answer is 0.377 to 0.479. Always round to 3 decimals in stat. This is our actual interval. If I were to put it in the on my normal curve, I'd have from 0.377 to 0.479. And I know I did this earlier. Calculator, bear with me just 1 second. I'm still trying to keep it under 20 minutes. I'm only at 16. Stat test. I'm doing it myself right now. I know you can't see what I'm doing. I've already got it all in there. Calculate. Oh, p hat was 0.428. So this right here is 0.428. That's what's in the middle. So that was the do part. If you've done all this and ran out of time, at least you would get a 3 out of 4 on this problem. However, that would be really sad because the conclusion is a piece of cake. You could go back, flip your paper over to the notes right now, and it has the previous page has a fill in the blank. Now, in the fill in the blank on the previous page, it says I am, but for some reason we always talk in terms of we with this whole book and everything. So my conclusion's right here. And I like saying we because we all work together as a team. We are 90%, because that's the level we used, confident that the true proportion of blue beads in the class jar, because we're too lazy to pour them all out and count them. We're going to guesstimate what the true proportion of blue beads in the class jar is. Falls within, still reading from the previous page, the interval 0.377 to 0.479. Done. That's in context and it's the correct conclusion. Questions? Well, obviously I can't answer them. If you have questions, write them down and we'll discuss them next class. If you are a B-Day and you're home in the snow right now, because it's Tuesday and well, no, right now it's only Monday, but if it snows tomorrow, I sure hope you watch this. And no, there is no quiz on section 8.1 and 8.2 the following class. I don't think you're ready for that yet. We're going to review and have some edible data. So hopefully you're ready to do that and we can continue on and do our activity and do section 8.3. Yay! All right, see you next class. Bye.